Hi, my name is Will Hartog, and I'm a fifth-year PhD candidate in statistics at Stanford University, advised by Li Hualei. I work on problems related to multiple hypothesis testing and causal inference, especially in settings with sequential data. I am honored to be a recipient of ARC's funding, and I am excited to present my work at the symposium this April. My most recent project is joint work with Yuxiang Luo and Will Fithian from UC Berkeley, and concerns the estimation of the local false discovery rate for empirical Bayes estimates. I will explain what all these terms mean. Say we have data for many units, and we want to estimate the mean of each. Because of noise, these measurements may vary greatly from the true value we want to estimate. But if we have a prior distribution for the underlying means, we can shrink the measurements to better estimate the true values. This process is called empirical Bayes, because it shrinks without Bayesian assumptions that may be incorrect. This kind of estimation is sometimes colloquially called regression to the mean, since future measurements for each unit will likely be closer to the overall mean. The plot on the right shows raw, noisy data in red, and the narrower, shrunk data in blue. Once we have empirical Bayes estimates, we would like to say, given a shrunk value delta, what is the probability the unit actually has a null mean of 0, which means no effect? Since we make no Bayesian assumptions, this is a tricky process. But we are able to get a frequentist estimate of this probability, which is shown in the plot on the right. Our estimate, in red, is an upper bound on the true probability of a null, in blue. Note that as the value of the shrunk estimate increases, the probability of a null decreases. This method can be useful in practice when we have limited previous information on our measurements. In the data setting of Klein et al. 2022, they measure how much each of 108 firms discriminates against racial minorities in hiring given a group of applications. Our method estimates the probability of no discrimination on the y-axis from the shrunk value estimate on the x-axis, and finds that the top 23 firms have a less than 10% probability of having no underlying discrimination. This estimate is frequentist, meaning that if we continue to repeat the experiment, 10% of units with a delta value of 1.5 would be truly null. Thank you.